Metal boxes must be grounded according to the National Electrical Code. Conduit must be bonded to the electrical panel. PVC conduit cannot be bonded. In the scenario where metal boxes are bonded with the green wire is bonded to the panel and PVC conduit is being used, there is a potential issue. PVC conduit cannot be bonded, meaning the metal boxes may not be properly grounded. Therefore, replacing the PVC conduit with electrical metallic tubing, or EMT, would be the recommended course of action to ensure proper grounding of the metal boxes. It is important to note that National Electrical Code, or NEC, requirements may vary depending on the specific situation and jurisdiction. It is always advisable to consult with a qualified electrician or refer to the most up-to-date version of the NEC for specific guidance. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to return to the source, which helps to trip a circuit breaker or fuse and to energize the circuit in the event of a fault. This protects people from electric shock and reduces the risk of fire. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences between different metal parts, which can also cause electric shock. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are based on years of experience and research, and they are designed to ensure the safety of people and property. When installing electrical systems, it is important to follow the NEC requirements carefully. This includes using the correct types of grounding and bonding conductors, and making sure that all connections are properly made. PVC conduit is a type of plastic conduit that is often used to protect electrical wiring. It is lightweight, easy to install, and resistant to corrosion. However, PVC conduit is not conductive, which means that it cannot be used to ground electrical systems. EMT, or electrical metallic tubing, is a type of metal conduit that is often used to protect electrical wiring. It is stronger than PVC conduit and can be used to ground electrical systems. When using EMT to ground electrical systems, it is important to make sure that all connections are properly made. This includes using grounding bushings and lock nuts to ensure a good electrical connection between the EMT and the metal boxes. Metal boxes are used to enclose electrical outlets and switches. They are typically made of steel or aluminum and must be grounded to protect people from electric shock. When grounding metal boxes, it is important to use the correct size grounding conductor and to make sure that all connections are properly made. The green wire is typically used as the grounding conductor in electrical systems. It is connected to the metal box and to the grounding bus in the electrical panel. The grounding bus is connected to the earth, which provides a low impedance path for fault current to return to the source. When the green wire is bonded to the panel, it creates a direct connection between the metal boxes and the earth. This helps to ensure that the metal boxes are properly grounded. If PVC conduit is used, it cannot be bonded. This means that the metal boxes may not be properly grounded. In this case, it is recommended to replace the PVC conduit with EMT to ensure proper grounding of the metal boxes. Consulting with a qualified electrician or referring to the most up-to-date version of the NEC is always advisable. This ensures that the electrical system is installed in accordance with all applicable codes and regulations. This will help to protect people from electric shock and reduce the risk of fire. Additional considerations for grounding and bonding include: firstly, the size of the grounding conductor. The size of the grounding conductor must be appropriate for the size of the circuit. The NEC provides tables that specify the minimum size of the grounding conductor for different circuit sizes. Secondly, the type of grounding conductor. The grounding conductor must be made of copper or aluminum. Copper is the preferred material because it is a better conductor of electricity. Thirdly, the grounding connections. All grounding connections must be properly made to ensure a good electrical connection. This includes using grounding bushings and lock nuts to connect the grounding conductor to metal boxes and equipment. Fourthly, the ground rod. A ground rod is a metal rod that is driven into the earth to provide a low impedance path for fault current to return to the source. The ground rod must be made of copper or steel and must be at least 8 feet long. Fifthly, the ground wire. The ground wire is a wire that connects the grounding bus in the electrical panel to the ground rod. The ground wire must be made of copper or aluminum and must be the same size as the grounding conductor. Sixthly, the water pipe. A metal water pipe can be used as a grounding electrode if it is in direct contact with the earth for at least 10 feet. The water pipe must be connected to the grounding bus in the electrical panel with a bonding jumper. Seventhly, the building steel. The steel frame of a building can be used as a grounding electrode if it is in direct contact with the earth. The building steel must be connected to the grounding bus in the electrical panel with a bonding jumper. Eighthly, the concrete encased electrode. A concrete encased electrode is a grounding electrode that is encased in concrete. The concrete encased electrode must be at least 20 feet long and must be made of copper or steel. Ninthly, the equipment grounding conductor. The equipment grounding conductor is a wire that connects the metal parts of electrical equipment to the grounding bus in the electrical panel. The equipment grounding conductor must be made of copper or aluminum and must be the same size as the circuit conductors. Tenthly, the bonding jumper. A bonding jumper is a wire that connects two or more metal parts of an electrical system together to create a common ground potential. Bonding jumpers are typically used to bond metal boxes, conduit, and equipment. It is crucial to understand the nuances between grounding and bonding as they are distinct but interconnected concepts. Grounding establishes a connection to the earth, providing a reference point for electrical potential and a path for fault current. Bonding, on the other hand, ensures that all metallic parts of an electrical system are at the same electrical potential, minimizing the risk of shock. In practical applications, consider a scenario where a metal enclosure houses electrical components. The equipment grounding conductor connects this enclosure to the grounding bus in the panel. This connection ensures that if a fault occurs and the enclosure becomes energized, the fault current will flow back to the source, tripping the circuit breaker and energizing the circuit. Without this grounding connection, the enclosure could remain energized, posing a significant shock hazard. Now, consider a scenario where multiple metal enclosures are used in a system. Bonding jumpers are used to connect these enclosures together, ensuring that they are all at the same electrical potential. This prevents voltage differences between the enclosures, which could also lead to electric shock. Understanding the NEC requirements for grounding and bonding is essential for ensuring the safety of electrical systems. These requirements are complex and can vary depending on the specific application. Therefore, it is always recommended to consult with a qualified electrician or refer to the most up-to-date version of the NEC for specific guidance. In addition to the points already covered, it's important to highlight the role of overcurrent protection devices such as circuit breakers and fuses in conjunction with proper grounding and bonding. These devices are designed to interrupt the flow of current in the event of an overcurrent condition such as a short circuit or ground fault. When a ground fault occurs in a properly grounded system, the fault current flows back to the source through the grounding conductor. This high current flow causes the circuit breaker to trip or the fuse to blow, de-energizing the circuit and preventing a potentially dangerous shock hazard. The effectiveness of overcurrent protection devices depends on the integrity of the grounding and bonding system. If the grounding and bonding system is not properly installed or maintained, the fault current may not be high enough to trip the circuit breaker or blow the fuse, leaving the circuit energized and posing a shock hazard. Therefore, it's crucial to ensure that the grounding and bonding system is properly installed and maintained in order to provide adequate protection against electrical shock. Another important aspect of grounding and bonding is the concept of impedance. Impedance is the opposition to the flow of alternating current. In grounding and bonding systems, it's important to minimize impedance in order to provide a low impedance path for fault current to flow back to the source. High impedance in the grounding and bonding system can limit the flow of fault current, which can prevent the circuit breaker from tripping or the fuse from blowing. Several factors can contribute to high impedance in the grounding and bonding system, including loose connections, corroded conductors, and long conductor lengths. Therefore, it's important to use proper installation techniques and materials to minimize impedance in the grounding and bonding system. Regular inspection and maintenance can also help to identify and correct any problems that could increase impedance. Furthermore, surge protection devices, or SPDs, play a vital role in protecting electrical equipment from voltage surges. While not directly related to grounding and bonding, SPD work in conjunction with these systems to provide comprehensive protection against electrical hazards. Voltage surges can be caused by lightning strikes, utility switching, and other events. These surges can damage or destroy sensitive electronic equipment. SPD are designed to divert surge current away from protected equipment and back to the source. In order for SPD to function properly, they must be properly grounded. The grounding conductor provides a low impedance path for the surge current to flow back to the source, preventing it from damaging protected equipment. Therefore, proper grounding is essential for the effective operation of SPD. Also, when working with electrical systems, it's important to use proper personal protective equipment, or PPE. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. Insulated gloves protect against electric shock, while safety glasses protect against flying debris. Arc-rated clothing protects against the thermal hazards of an arc flash. Arc flashes are explosive events that can occur when electrical equipment is energized. They can cause severe burns and other injuries. Therefore, it's important to wear appropriate PPE when working with electrical systems to protect against these hazards. Remember, electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. If you're not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. In the context of the initial question, the teacher's advice might stem from specific local interpretations or historical practices. However, the NEC generally errs on the side of caution and promotes the most robust grounding and bonding practices. Therefore, adhering to the NEC recommendations, especially regarding the use of EMT instead of PVC in situations where grounding is critical, is generally the safest and most reliable approach. The NEC is updated regularly to reflect new technologies and best practices. It's important to stay current with the latest version of the code to ensure that your electrical work is safe and compliant. Changes to the NEC can impact grounding and bonding requirements, so it's essential to be aware of these changes. Continuing education and training are also essential for electricians and other electrical professionals. These opportunities provide valuable information on new technologies, code changes, and best practices. Staying up to date on the latest information can help you to perform your job safely and effectively. To summarize, proper grounding and bonding are essential for ensuring the safety of electrical systems. The NEC provides detailed requirements for grounding and bonding, and it's important to follow these requirements carefully. When working with electrical systems, it's important to use proper PPE and to take all necessary precautions to protect yourself and others. Remember, electrical work can be dangerous, and it's best to hire a qualified electrician if you're not comfortable doing the work yourself. Finally, always consult the most recent version of the NEC and local regulations, as these take precedence.